Okay, good afternoon everyone. I'm here in the Maricosta Chemistry Lab and I'm going to be walking you through a lab called the Stoichiometry of a Single Replacement. And shout out to Mr. Locke because he is here helping me film this video. Alright, so first I'm going to put on my protective goggles. Next I'm going to take 150 milliliters of tap water and I'm going to start that heating over the Bunsen burner. Turn on the gas here. Oops, wrong one. This one. And we'll get that heating. While that's heating, I'm going to go ahead and mass 5 grams of copper sulfate. So copper sulfate is an ionic compound. It is also a hydrate. So this is copper sulfate pentahydrate. So it actually has 5 water molecules bonded to it. It is toxic by ingestion, but nobody's going to ingest this. So I'm going to put the weigh boat on, zero the scale, and then I'll use the scupula to mass 5 grams. And if it's not exactly 5, that's okay. We'll just record the exact mass. Okay, so 5.06, that's close enough. And I did have several students at the beginning of the year say that they wanted to study chemistry because they love the show Breaking Bad. And you may notice that this looks suspiciously like Walter White's product, but it is in fact not. It is copper sulfate pentahydrate. So let me make a note of the exact mass. It was 5.06 grams. All right, and I'm going to add that to the solution. Then we have our stirring rod. We're going to let that dissolve. So remember, a property of ionic compounds is that they dissolve easily in water, especially when it's heated water. Okay, so I'll come back to that in a minute. The other thing we need is, our other reactant is going to be aluminum. So we just have a sheet of aluminum foil. And I just want to get it as close to 0.3 grams as possible. So this came out to be 0.32, so that's good enough. All right, I'm going to give this another stir. And while that's heating up, we want to get it to a gentle boil. I'm going to keep the aluminum foil as flat as possible. So first of all, think about why it might be a good idea to keep this flat during the reaction instead of crumpling it up. And then I'm going to rinse it off in a solution of, this is 1 molar hydrochloric acid. So I'm just going to soak this in here for a minute. Let me grab some tongs because I forgot those. Alright, and then I'm going to rinse it off in some distilled water. Actually, maybe I'll just leave it in the wash bottle. So think about why it might be a good idea to soak this in acid and then rinse it off with the water. So that's another question. Now I'm going to add this to the mixture, trying to keep it as flat as possible. Now, I won't be able to keep it completely flat. And then we'll just let the magic happen here. Okay, and you notice that on the sides of the foil, it's starting to turn a brownish color. So this is indicating that the replacement metal replacement is starting to occur. And a lot of times people say, oh, it looks like rust. Well, and it does look like that, but it's not. Think about what your two metals are involved in this lab. And I'm going to turn down the heat a little bit so it doesn't overboil. And we'll let this go for about 5 minutes or so. So Mr. Locke, if you want to pause the video for a second, you can.